Good morning to everybody that's joined us so far. We will get the presentation started here in about 4 minutes. You have a chat window and a question window in your control panel. If you have questions, we'll be monitoring them there. We'll talk a little bit more about that coming up. So we'll get started here in about 4 minutes. Good morning, everybody. It's 11 o'clock. I want to introduce myself. I'm Adam Jackson. I'm the Regional Vice President for Powermation, serving in our regions 3 and 4, which is Northwest Indiana, Illinois, Iowa, and Nebraska. I want to start by thanking you all for joining us for the second in our series of food and beverage focused presentations. Some of you heard this last week, but for those of you that are unfamiliar with Powermation, I want to give you a 10,000-foot introduction. We're a technology and solutions focused distributor of controls and automation solutions based in the upper Midwest. Since we were founded in 1961, we have maintained our position on the forefront of manufacturing, pushing ourselves daily to deliver innovative automation solutions with exceptional customer service. If this is your first experience with us, welcome. Please take a few minutes after today's presentation to check us out at www.powermation.com. Before I introduce today's presenter, I wanted to also make sure I invite you to Festo's virtual trade show on August 5th and 6th. You'll be able to experience Festo's full range of pneumatic, electric automation, and process automation solutions, smart factory technologies, and innovative engineering tools from the relative comfort and safety of your office. You can find more information from your PowerMation sales rep at festo.com. This morning, Steve Bain will be our presenter. Steve is the industry segment manager for food and beverage for Festo US. A chemical engineer by degree, Steve worked for Kimberly-Clark and Ecolab in engineering roles before joining Festo in 2011. Steve works on a national level as primary interface between Festo employees and customers to discuss food applications and compliance with food regulations. He resides in Denver with his wife and 2 young children and enjoys skiing and hiking when he can find time. This morning, we'll be reviewing Festo's products for the food industry and how utilizing components designed for the food industry can bring other benefits to your process, such as energy savings and additional machine uptime and availability. As we get started this morning, we will be recording this presentation, and you'll be able to find all source material available to you in the handout section of the presentation control panel. On that control panel, you'll also be able to submit your questions in the chat area or the question tab. Again, thank you for joining us. Steve, please go ahead and take it away.
All right, thanks a lot. I'll jump right into it. So this is part 2 of a 3-part series on FSMA. Last week we reviewed what FSMA is and what it means for equipment design. We'll review that very briefly, and then we'll talk about what additional benefits can come from compliance. So real quick overview of Festo. We are a 3 billion euro company headquartered in Europe, in Germany. We are also the world's largest supplier of pneumatics for the food and beverage industry. So we see a lot of applications, and we work with a lot of customers. And so we really have become an expert in this field of helping to steer customers towards better compliance, towards better equipment design. Festo, you probably know us for our catalog products, but we also do a lot of customizations. We're the world's largest industrial training company, and we can do services like energy audits or equipment audits. As I mentioned, we also do a lot of customized components. So this is especially important for the food industry, where there's so many different applications and custom needs for different equipment. So as I mentioned, we'll do a real quick review of what FSMA is. FSMA is the Food Safety Modernization Act. It was signed into law in 2011, and it was the first major overhaul of good manufacturing practices, or GMPs, in 25 years at the time. And during that time, the supply chain changed a lot, automation changed a lot, and so there was a huge need to have a big change in how we look at the food supply chain. The major themes for FSMA were import safety. So looking at, we're importing about 15% of our food, and how do you know that the facility that food is being produced in is as clean as it is in the US? Well, now FSMA has to be, and a big part of that is being able to rely on third-party certification companies that can go in, certify that it meets the requirements, and now importers can rely on that. We're seeing that heavily starting to roll out through the actual supply chain, where major grocery store chains are only allowing product on their shelves that is from a facility that is certified. Another major update was updating the GMPs. So stronger language, should into shall, so it seems less optional. And then additional language about cross-contact and food allergens. Those weren't part of the CGMPs before because there really wasn't a focus. FSMA went from reaction to prevention. And one of the big changes too is this hazard analysis and risk-based preventative controls, HARPAC. So every plant has to evaluate their hazards, identify and implement preventative controls, monitor those controls, and then maintain records and conduct verification activities to ensure those controls are in place. And this is a big deal for factories to have to implement this process. And on top of that, the FDA can now have mandatory inspections of facilities, and the FDA will have access to all those records that you're supposed to be keeping about your HARP verification activities. So this documentation and this prevention aspect of FSMA is really quite powerful. With that too, the FDA can now enforce mandatory recalls, and they can do that when there is a reasonable probability that the food is adulterated. And they define adulteration as where food has been prepared, packed, or held under unsanitary conditions, where it may have become contaminated with filth, or it may have been rendered injurious to health. And so that language really opens up the possibility that a mandatory recall could be enforced just due to unsanitary conditions of the factory, even if the food isn't contaminated. And then on top of all that, there's something called the PARC doctrine, where executives of companies can be held accountable for food safety issues, even if they weren't aware that the specific offense was even happening. So ignorance isn't even an excuse within a food company. So we did a deep dive into Title 21, Part 117, which is where the majority of FSMA lies. And the 11740 specifically is equipment and utensils. And we did a real deep dive into each one of these laws. We're not going to go through them today. If you want to learn about this, we'll be hosting the previous webinar on the Festo web blog, so you can watch that video. But the main takeaways were that machinery needs to be designed to be cleanable. It's not just enough to actually clean it. The machinery itself has to have that design principle built into it. Food contact surfaces cannot have cracks or crevices or introduce contaminants. Machinery needs to be capable of withstanding cleaning processes. Even machinery that does not contact food needs to be capable of being cleaned. And at a minimum, a 0.1 micron filter at point of use should be utilized for compressed air with direct food contact. From that, we had just kind of broad strokes, from a Festo perspective, what are some things you can do? And one is to use components with reduced cracks and crevices. Use components with FDA-approved polymers for seals. Use components with NSF-H1 grease, especially over the food zone. And then standardize on M threads and G threads, which are parallel threads, so to eliminate that crack and crevice created by a tapered thread. But what additional benefits can come from that? So as an example, we said to use clean design components. These components have large radii smooth surfaces, easy to clean, yes, and being compliant, but a huge additional benefit here is that if you can clean your machine better and faster, in theory, you can reduce the amount of time that you're cleaning significantly. And if you have better cleanability, that means faster cleaning, which means you can run your machine more, which means your OEE, or your overall equipment effectiveness, can increase because your machine has higher availability. This is probably one of the biggest benefits of focusing on cleanability from a profitability standpoint. If you can cut your cleaning time down, your machine operation time can go up. Another example might be using the Clean Design DGRF. So this is one of our Clean Design actuators, food safe grease, food safe seals, but it's also the strongest Festo actuator for a guided cylinder, extreme bearing strength, just due to the design. So if you're looking at even a non-wash down application, but looking for strong bearing support, it's a great actuator for that. It's also one of the better actuators we have for dusty conditions. So it comes with slide bearings, which are better than ball bearings for dusty environments. But then an interesting aspect too is that the yoke plate, when it closes all the way down, leaves a space between the plate and the body. And so if there is a lot of dust or debris, it won't compact that into the seals and cause a premature failure. Another product we talked about was the VZQA pinch valve. So this is an aseptic design. It has clamp connections so you can easily disassemble it so you can clean your equipment. Well, some other benefits that come with the VZQA are that it's very, very small. It's not much bigger than the pipe itself. And so you can create, put a lot of valves into a very tight space and might create some opportunities. Another interesting thing is that it uses a lot less energy than a comparable ball valve or butterfly valve with a quarter turn actuator. So I did some just quick look, and a half-inch ball valve consumes about 0.6 liters of air per cycle, while a VZQA is less than 0.1. So a much smaller footprint. Next, food contact surfaces cannot have cracks or crevices or introduce contaminants. So we already talked about threads, about how a G thread is more sanitary than a tapered thread. A tapered thread, when you screw it in, also dulls the threads, and so you could create metal fragments during that process. So that's another potential contaminant. And then you have the sealing tape, which is another potential contaminant. So again, tapered thread is not very good for food safety. But if you're going to go to G thread, there's a lot of benefits that come with that. So one is that you can screw in and screw out a G thread many times without wearing down the threads or having issues, while a tapered thread can only do this maybe 3 or 4 times. And so if you have to replace an actuator, maybe now you don't also have to replace a fitting. And that's a big benefit. Energy savings too. Tapered threads are very difficult to get a bubble tight seal. And when you screw in a tapered thread, you end up creating a small air channel that spirals up through the threads. And so unless your sealing is perfect, you're going to have a leak. And with a parallel thread, you eliminate that because everything gets sealed properly with the shoulder seal. Also, like from an engineering perspective, when you have a tapered thread and you're screwing it in, the height of that thread is really kind of uncertain. And so, you know, if you're looking at kind of a tight tolerance application, it's hard for the engineer to be able to verify, or is this going to fit or isn't it? Where with a G thread, you know exactly how deep that's going to be, and you can verify it's going to fit. And then last, there's you know, a tapered thread. It's pretty easy to over torque or under torque. It's hard to get that torque range right, and with a parallel thread, it's very hard to over torque that. And so, from an installation standpoint, again, parallel threads are a better option. Also recommend the use of NSF grease, especially over the food zone. So a lot of pneumatic and electromechanical components come with factory installed grease. Where possible in food, that should probably be NSF H1. But what, you know, if I were to standardize on that, what benefits would that bring? Well, the first thing is good news is that you don't get bad benefits or negative aspects to that. You know, thorough testing from Festo's, we have what we call our torture lab, where, you know, we put all of our actuators and valves through rigorous tests, and NSF grease does not hurt our performance. So if you're using components with NSF grease, you're going to get the same or better performance as a standard Festo cylinder. And then also helping to reduce your inventory. So instead of having one cylinder that's NSF grease because it's over the food zone, and then another one that isn't, you can consolidate your inventory into a single cylinder. And then you have also less risk of someone maybe choosing the wrong cylinder and putting it over the food zone in an accident. So if you're going to standardize it, there's not a lot of downside to that. We talked about how using Festo self-adjusting cushioning, which is PPS, eliminates the adjustment screw for adjusting the air cushion. There's a lot of additional benefits that PPS has, though. So a big one is that PPS cushioning adapts to changing conditions. So if you were to have a PPV adjustable cushion, set it for a given application, you're setting it for the proper cushioning for that air pressure at that flow control, pushing a certain load with a given amount of humidity in the air with a certain amount of friction on the rod. And you might be able to optimize it, but over the course of months or years, those wear characteristics change, and PPS cushioning adapts to that. And so your cushioning will be good now and it'll be good in the future. And that's a huge benefit. And you get that benefit at a reduced cost because there's less mechanical parts. Our cost for that part is reduced by about 1 or 2%. And so you can buy these cylinders for less expensive than adjustable cushioning. And then another big one is faster installation. So instead of having to install a cylinder, go to the manual overrides on the valve, toggle it, see how it reacts, go adjust the cushioning, go back and forth, you completely eliminate that step. So whether you're doing an installation of a machine for the first time and you have to go set the cushioning on 20 cylinders, or you're an end user and you're replacing a cylinder between production runs, in either case, you're eliminating a lot of time, potentially even like not needing 2 people to go do that process could be a really big deal. Next, so this is the slide of showing all of the different Festo cylinders with PPS actuators, and also highlighted which ones have those FDA approved seals. So the third key idea was that machinery needs to be capable of withstanding cleaning processes. And the recommendation is to use corrosion resistant components where you can. That seems obvious in food, but there's a lot of things where even in non-food applications, things get oxidized over time. Just general rust happens. And so corrosion resistant components will give you longer life in general. And then most of I think all of our corrosion resistant components also incorporate MSFA grease and FDA approved seals. So there's built-in compliance to that. Using corrosion resistant components tends to get you more into the food spectrum of components, which means you're probably going to be more compliant. You should always double check that, but it's a good way to go. Another recommendation was to use FDA approved tubing. So if tubing is FDA approved, it means the polymer that it's made with falls under the generally recognized as safe list from the government. And so there's all these polymers, and the polymers that are used for these are FDA approved. And we have 3 tubes that are FDA approved for Festo. One is PONH, one is PTFEN, the other one is PFAN. So if you're going to use those tubings, what additional benefits? Well, one is that all 3 of them are also hydrolysis resistant. So even if it's not a food environment, they aren't going to deteriorate due to wet or humid environments where water itself can interact with the tubing material and help break it down. PTFEN and PONH, if the PONH is black or blue, also has high UV resistance. So you can use these in outdoor applications. PONH itself is a great all-around tubing, very flexible, low cost. It's my go-to if I'm going to look at a new application. And then PTFEN and PFAN are both good for high pressure and high temperature. So, maybe you're putting something next to an oven and you're not sure kind of what that heat radiation looks like. Well, this kind of takes away that risk. And then if you're in an application where you're looking for this EC 1935/2004 certification, which is a growing requirement in Europe for food applications, our PFAN tubing is 1935/2004 certified. So we can fulfill that need if it's required. Another recommendation for withstanding cleaning processes is just higher IP ratings. And the Festo MPAC is IP69K rated, which means it can withstand high pressure washdown. And it does that through 2 really cool design features. One is the seals themselves. When they're assembled, if you were to spray it with high pressure, it actually helps enforce the seal even more. So the design of the seal helps to make it even better in high pressure washdown situations. And then we also have a redundant seal. And so your outer seal is the one that reacts to the pressure. The inner seal also helps protect the electronics. So even if that outer seal was to get breached, the inner seal is still going to protect the electronics. And to my knowledge, we haven't had a field failure yet of this product. And so that's really good, awesome product from a washdown perspective. But what are some other benefits that come with this? First is that your control cabinet size could go down or be completely eliminated. So in the example you're showing here, this is a brewery. They wanted a valve manifold in the cabinet, nothing else. And the MPAC compared to a valve manifold in the cabinet was less than half the cost. And so this was a great cost saving in addition to also being very well suited for this environment. The MPAC also has incredible pneumatic flexibility. So of every valve manifold that Festo has, this has the most flexible pneumatic capabilities. You can configure every valve slice to have 5 ports, and every one of those 5 ports can be completely independent of the valve next to it, meaning you could run one valve forward, one valve backwards, have a bunch of different pressure zones. And so if you have an application where there's either a lot of pressure zones or just a lot of complexity, the MPAC might end up being the most compact or more cost-effective solution that we have. An energy savings. So quick little application question, which one of these has more volume? CRDS&U with a 20 millimeter bore, 80 millimeter stroke, moving in one direction has a volume of 25 cubic centimeters. P&H tubing, 6 mil OD, 20 feet long, not that long of a run compared to a lot of things we see. What that volume? 75 cubic centimeters. So in this application, filling the tubing with air is 75% of the energy usage of this. And that's astonishing for a lot of people. But what if you were to use MPAC? So you've got this long run of tubing from a cabinet, but if you were to clip that, put an MPAC in, and now you've gone, let's hypothetically, from 20 feet of tubing down to 6 feet. Your energy cost on an annual basis, I have some assumptions down there, drops from $85 down to $41. So over 50% energy savings just by being able to move your valves closer to the process. And that's a really big deal for some customers and for some applications, especially if you can incorporate this on the design perspective. So you're not, $85, $40 of your savings isn't going to justify doing this. But if you can do this from the get-go and build this into your specifications, you can save a lot of energy. Additional benefit by moving your valves closer to the process too is that your reaction time becomes a lot more consistent. And so if you have applications like rotary fillers or really any filling operation or sorting applications or reject applications, the MPAC can provide a lot more consistent timing because that tubing length is shorter. And with that too, if your tubing length is shorter, your cycle time can be faster. And so for some applications, you might actually be looking at being able to ramp up your production speed just because your valves are closer to your process. And then, so if you want to move your valves closer to your process, which in all cases is generally a good idea, but let's say you have a situation where you have these sandwich pressure regulator plates. Maybe every valve needs to have its own pressure zone or AB pressure regulation or things like this. The MPAC allows you to do something pretty cool to where you can have your valves close to the process, but you could use, let's say, an MS4 LRB regulator rack to control each of those pressures. And so you can have your adjustment points where it's visible, where you can access them, where maintenance can get in there and do things, but your valves are still tucked away in the process close to the application. And so from just a cost perspective on this too, MS4 LRB with an MPAC is about equivalent in cost to a manifold with these sandwich pressure regulator plates. And so, using these concepts doesn't always mean higher cost, but it does provide a lot of value. Even machinery that does not contact food needs to be capable of being cleaned. So one of the things that we talked about was using this ELGAF1 or other clean design actuators on your packaging equipment, just to be make sure that you can wipe it down, that you can clean it, because that's what FSMA says you need to be able to do. Well, in addition, if you're going to use the ELGA, one of the coolest things is that it's actually the fastest actuator that we offer if you get the RF roller version. So we can make this in lengths up to 10 meters long, and the RF version has a maximum speed of 10 meters a second, which is just flying. And so if you're going to use these products, you might be able to have your machine built to be faster. And at a minimum, a 0.01 micron filter at point of use should be utilized for compressed air with direct food contact. That's actually not written into the law, but as you're looking around and looking for various air quality specifications from trusted sources, one that we found is that SQF recommends, SQF is one of the third-party certification companies, in their guidance documents, they recommend a minimum of a 0.1 micron filter located at point of use. So if I was somebody who was responsible for specifying compressed air quality, that might be something I lean on. But Festo's created a range of complete air preparation units designed for various air qualities. And all of these have 0.01 micron filter. And so if you are trying to be compliant, if you're trying to meet various air quality classes, you can just pick an air quality class to determine your flow rate. And now you have a single part number to help meet that air quality requirement. But these air prep units also have some really cool things. First, because you're providing better air, you're going to get longer component life. And so you might have reduced overall equipment costs just because your valves are getting treated with that much better air. With that single part number, you can have easy standardization. Either one for trying to meet everything, or maybe a couple for different flow rates at a given air quality. And these assemblies are in stock in Ohio and available for immediate shipment. So this isn't going to slow you down. These assemblies also take a lot of TPM considerations into effect. And so red-green pressure gauges, as an example, allow an operator to walk by and realize something is wrong. So instead of just calling maintenance and saying, hey, the machine's down, they can call maintenance and say, hey, the pressure is off, and maybe maintenance can fix that from the maintenance room instead of having to walk up to the machine to determine that for themselves. These are TPM type concepts. If you'd like to learn more about that, there is a TPM document in the downloads that highlights some Festo solutions for TPM. And then another example is the red-green indication on the filter. So as the differential pressure increases due to the filter collecting more contaminants, that will change from green to red, and then you know it's time to change it. These assemblies also include a manual on-off with a lockout tagout. So for machine safety reasons is very important, but also, I've been in a lot of factories where it's not really clear even how to dump the air for a filter. And so, how often do you think that filter gets changed if you can't even reduce the pressure to be able to remove the bowl? And so this is a really important part. And then the regulator also has a lockable slot in it as well. And so you can put a lock on the regulator, and that's great for tamper-proofing, so that operators can't come by and just adjust it when they think something needs to be tweaked. So Festo really does have a great portfolio for the food industry, from air preparation to a full line of actuators designed with clean design concepts, to our IP69K MPAC manifold, our process valves, fittings and tubing. It's a great portfolio for companies looking to make their food equipment better, more hygienic, more energy efficient, higher machine availability. These are all things you can incorporate once you really start to try to incorporate clean design products. Festo has 30,000 products. Also in the support documents is this guide for new products for the food industry. So if you're looking at a new application, a new machine, maybe you're retrofitting an old machine, this guide takes that 30,000 products and breaks it down to just the products families that we would recommend for a new food application. So some final recommendations. Again, request products with NSF-H1 grease, especially in the food zone. Request products with FDA approved materials. Standardize on M threads and G threads. Request products with reduced cracks and crevices. And request Festo. Festo has the most comprehensive line of pneumatic products for food applications. Before we get to questions, part 3 will be next Tuesday, August 4th. And this will be a deep dive into the products themselves. So if you want to learn more about, let's say, the DGRF actuator, what options are there, why would I choose that option and when, that is going to be the focus. We're also going to do a deep dive on air quality. So if I have a 40 micron filter versus a 5 versus a 1 micron, what kind of air qualities can I expect with that? And we'll walk through that process. On August 5th and 6th next week, we have the Festo Experience online automation fair, and really excited about this. There's 16 booths, a lot of presentations, there's a networking lounge, and so if you want to learn about new Festo applications or new products, if you want to talk with experts about certain applications, this is a great time to be able to do it. Think about this like it being an actual trade fair and be able to go talk to people about things that you're trying to work on. We're going to be there, and I'm really excited about this. So with that, I'll open it up for questions.
Steve, thank you very much. One of the questions that came in is you talked about the 5 strategies in lots of areas where opportunity exists to improve facilities. What would you say is probably the most common or the lowest hanging fruit for areas to look at first?
Honestly, based on my experience, it's actually tubing selection. Like it's such an inexpensive part relative to the entire process, and you see a lot of companies going cheap on their tubing, and it hurts them down the road because they get leaks, they get premature failures, they get random breakdowns, and it's a very easy thing to fix. And to me, it's also kind of a litmus test of, all right, if you want to get serious about food safety, if you want to get serious about being able to drive change within your organization, and you can't even change your tubing, like that's probably a good indication that your organization is not prepared for actual food safety compliance.
You talked about M threads and G threads and looking for ways to implement them. How big of a task is it for an end user to do an audit, to go through and to make those changes? What are the peripheral things that will come with that they should be aware of?
So if you have ISO cylinders, if you have metric cylinders, this is extremely easy to do. So there's 2 types of fittings that can thread into a BSPP port. One is an R thread, which is tapered. One is a G thread, which is parallel. So if you have R threads, changing those to G threads is extremely easy to do. On the NPT side, it's certainly going to become a bigger challenge. So NPT female ports can only accept NPT male threads, and so you will have exposed threads at that point. So changing those actuators out to be metric ported would be the ideal situation over time. And that's where really driving that specification back into machine builders to say, listen, I need G-thread fittings, G-thread actuators out the get-go can help avoid future issues.
Before I get to this next question, just want to remind those that are in attendance, there's a questions and a chat tab in the control panel. You can submit questions there if you have them. But while we look to wait till some of those come in, who has, from a governmental or a regulation position, who has authority to come in and investigate the cleanliness or the operational characteristics of our food and beverage manufacturing operations?
So it's, assuming we're not talking about the meat industry or the egg industry, the FDA has the authority. If it's a meat factory, then that's regulated by the USDA. If it's a meat factory that also makes finished goods, then the FDA and the USDA have authority. So it does get a little complicated that way. But the other part of this is also the third-party certification companies. And so they'll come in and they'll do an audit. You're paying them to come in and do an audit, hoping that you get a good score so that you can claim that you're certified. And that is really what a lot of companies are doing. And so if you can get certified, if you can verify that you have done all these different processes, yeah, you're going to be a lot more confident about if the FDA does come in and do an inspection.
Perfect. Well, Steve, we just want to thank you for your time and expertise. We'll look forward to next Tuesday to the final installment of this three-part series. Again, for those of you that are watching, please make sure you join us for the Festo virtual fair next Thursday and Friday, the 5th and 6th. We look forward to our time together then. Or sorry, Wednesday and Thursday. Calendars are getting weird. Thanks very much.
Yeah, thanks.